Okay, guys, I've got everything written down on this one already. This problem I'm going to work through with just a highlighter because there's a lot of stuff to go through. But essentially, we have a compound and it has carbon, hydrogen, and nitrogen. I'm giving you the percent composition of the compound by saying that there is 13.41% hydrogen and 39.97% carbon. I'm asking you to calculate the empirical formula and the molecular formula. In this particular problem, I've given you another clue, and that clue is the molar mass. I've told you that the molar mass of the compound is 60.10 grams per mole. Now, what I'm going to do is I'm going to go ahead and write down my different atoms in my table. And of course, then the mass percent compositions can be written down as grams since we assume 100 grams. So I have 13.97 grams of carbon and 13.41 grams of hydrogen. But what's going on with nitrogen? How did I figure out how many grams of nitrogen are there? Because the problem doesn't say anything about the mass percent composition of nitrogen. Well, what do we know? We know that for nitrogen, or for any mass percent composition, that they all have to equal 100%. And so if I take that 100% and subtract it from the two mass percent compositions that I get, then I will be able to get the mass percent composition of nitrogen. So ultimately, the mass percent composition of nitrogen is 46.62%. And so I can include that in my table as 46.62 grams. Now, just like before, I would take the molar masses and I would calculate the number of moles that each one of those masses represents. So 39.97 grams of carbon divided by its molar mass, I get 3.328 moles of carbon. 13.41 grams of hydrogen divided by its molar mass, I get 13.30 moles of hydrogen. And taking 46.62 grams of nitrogen divided by its molar mass, and I get 3.328 moles of nitrogen. Now, again, I like to put those molar masses in my particular table in order to keep track of them. So 3.328 moles of carbon, 113.30 moles of hydrogen, and 3.328 moles of nitrogen. Now, what I need to do is I need to figure out the molar mass of, or I need to figure out the lowest whole number ratio of those numbers of moles. So in order to do that, I pick the two values that are the smallest and divide each number by that. Now I've got two values that are the same, so I can divide 3.328 by 3.328, I get 1. 3.328 by 3.328, I get 1. And then 13.30 divided by 3.328, I get 4. So what do I have going on here? Now I've figured out the empirical formula of the compound, CH4N. So I'm almost done. I've got the empirical formula. That's most of the work. Now I have to figure out the molecular formula. And so how do I do that? What's the secret to figuring out the molecular formula? Well, I'm given in the problem that the molar mass of the compound is 60.10 grams per mole. And so what I'm going to do is I'm going to take that empirical formula that I just calculated and figure out its molar mass. I get 30.05 grams per mole. When I divide 60.10 by 30.05, I get 2. So what does that mean? that means that I have 2 times the number of atoms in the molecular formula than I do in the empirical formula. So if I come back up here to the empirical formula and I multiply it by 2, then I have my molecular formula. So CH4N would become C2H8N2, and that is my molecular formula. And so I've finished with the problem getting both the empirical formula and the molecular formula. Okay, that's it.